struct in the C programming language is a complex data type declaration that defines a physically grouped list of variables to be placed under one name in a block of memory, allowing the different variables to be accessed via a single pointer, or the struct declared name which returns the same address. The struct can contain many other complex and simple data type in an association, so is a natural organizing type for records like the mixed data types in lists of directory entries reading a hard drive address, etc., or other mixed record type. The C struct directly corresponds to the assembly language data type of the same use, and both reference a contiguous block of physical memory, usually delimited by word length boundaries. Language implementations which could utilize half-word or byte boundaries were considered advanced in the mid-'80s. Being a block of contiguous memory, each variable within is located a fixed offset from the index 0 reference, the pointer. As an illustration, many basic interpreters once fielded a string data struct organization with one value recording string length, one indexing the previous line, one pointing the string data. Because the contents of a struct are stored in contiguous memory, the sysiv operator can be used to get the number of bytes needed to store a particular type of struct, just as it can be used for primitives. The alignment of particular fields in the struct is implementation-specific and may include padding, although modern compilers typically support the pragmapack directive, which changes the size in bytes used for alignment. In the C++ language, classes are an extension of structs. In other languages, like its C counterpart, the struct data type in C is similar to a class. The biggest difference between a struct and a class in these languages is that classes exist on the managed heap, while structs are allocated on the stack. Thus, when a struct is passed as an argument to a function, any modifications to the struct in that function will not be reflected in the original variable. This distinction differs from C++, where classes or structs can be allocated either on the stack or on the heap, with an explicit pointer. In C++, the only difference between a struct and a class is that the members and base classes of a struct are public by default. Declaration: the general syntax for a struct declaration in C is. Here tag name is optional in some contexts. Such a struct declaration may also appear in the context of a typed declaration of a type alias or the declaration or definition of a variable. Often, such entities are better declared separately, as in, for example, defines a type, referred to as struct account. To create a new variable of this type, we can write, which has an integer component, accessed by account number, and a floating point component, accessed by balance, as well as the first name and last name components. The structure S contains all four values, and all four fields may be changed independently. A pointer to an instance of the account structure will point to the memory address of the first variable, account number. The total storage required for a struct object is the sum of the storage requirements of all the fields, plus any internal padding. The primary use of a struct is for the construction of complex data types, but in practice they are sometimes used to circumvent standard C conventions to create a kind of primitive subtyping. For example, common Internet protocols rely on the fact that C compilers insert padding between struct fields in predictable ways. Thus the code is often assumed to work as expected, if the operate_on_ifoo function only accesses fields x and y of its argument because a C compiler will map the struct elements to memory space exactly as it is written in the source code, thus the x and y will point to exactly the same memory space in both structs. Struct initialization: there are three ways to initialize a structure. For the struct type, C89 style initializers are used when contiguous members may be given. For non-contiguous or out-of-order members list, designated initializer style may be used. If an initializer is given or if the object is statically allocated, omitted elements are initialized to 0. A third way of initializing a structure is to copy the value of an existing object of the same type. Assignment: the following assignment of a struct to another struct does what one might expect. It is not necessary to use memcpy to make a duplicate of a struct type. The memory is already given and zeroed by just declaring a variable of that type regardless of member initialization. This should not be confused with the requirement of memory management when dealing with a pointer to a struct. Pointers to struct. Pointers can be used to refer to a struct by its address. This is particularly useful for passing structs to a function by reference or to refer to another instance of the struct type as a field. The pointer can be dereferenced just like any other pointer in C using the operator. There is also an operator in C which dereferences the pointer to struct and then accesses the value of a member of the struct. C does not allow recursive declaration of struct. A struct cannot contain a field that is the type of the struct itself. But pointers can be used to refer to an instance of it. Here the instance L would contain a point with coordinates 3 and 7. Its next pointer would be a null pointer since the initializer for that field is omitted. The instance L in turn would have its own point and its next pointer would refer to L, type. Typedefs can be used as shortcuts, for example. Different users have differing preferences. Proponents usually claim, shorter to write, can simplify more complex type definitions, can be used to forward declare a struct type. As an example, consider a type that defines a pointer to a function that accepts pointers to struct types and returns a pointer to struct, without type. With type. A common naming convention for such a type is to append AT to the struct tag name, but such names are reserved by POSIX, so such a practice should be avoided. A much easier convention is to use just the same identifier for the tag name and the type name. Without typed for function that takes function pointer, the following code would have to be used. Although valid, it becomes increasingly hard to read. Here a second typed for a function pointer type can be useful. Now with the two typedefs being used, the complexity of the function's signature is drastically reduced. However, there are a handful of disadvantages in using them. They pollute the main namespace, however this is easily overcome with prefixing a library name to the type name. Harder to figure out the alias type, though most IDEs provide this lookup automatically. Typedefs do not really hide anything in a struct or union. Members are still accessible. To really hide struct members, one needs to use incompletely declared structs. See also, bit field, composite data type, union type, references, C struct memory layout. Stack Overflow, parameter passing in C, Kelly, Alabama. Pohl, Ira. A Book on C, Programming in CPA 418. ISBN A0-201-18399-4, IBM Linux compilers. Initialization of structures and unions. The new C standard, A section 6.7.8 Initialization A.